one last problem here, and this one we're going to do together because there are a couple of little tricky things. So the first thing I'm going to do, just like the last one, is I notice that I have an x squared, so I want to look at factoring that, and it will be a difference of 2 squares, just like the one before. This will let me identify my LCD as, let's see, I have an x minus 3 here, so x minus 3, and then I have an x plus 3 and an x minus 3 here, so I need to bring in that x plus 3. The x minus 3 is already accounted for, and then this one is an x plus 3, already accounted for. So my LCD is x minus 3, x plus 3, and I need to multiply each expression by what it'll take to make the denominator into my LCD. So here on the first one, 6 over x minus 3, I need to multiply by x plus 3. On this second one, I already have both pieces, so I don't need to multiply by anything. And then on this third one, I have the x plus 3, but I'm missing the x minus 3. Let's continue simplifying. And in fact, I'm not even going to write the denominator again. I know that in the next step, I'm going to cross it out, so might as well just cross it out here and just stick with dealing with the numerator. So let's do that. I'm going to say 6 times x plus 3. That'll give me 6x plus 18, and that's going to be equal to 8x squared. Remember, that was the term we didn't have to multiply by anything. And then a minus 4x squared, because notice this is a subtraction, so it's a negative 4x times x, and then a negative 4x times negative 3 will give me a positive 12x. All right, 6x plus 18, but I notice that I can combine 8x squared minus 4x squared and get 4x squared plus 12x. This time, since my x squared term is on the right and positive, I want to go ahead and move everything to the right. So I'm going to say 0 is equal to 4x squared plus 6x, that would be 12x minus the 6x on the left, and then minus 18. Now remember that the very first thing that you want to do when you are going to factor is factor out a GCF if there is one. And I see that there is a GCF of 2. So I want to factor that out, leaving me with 2x squared plus 3x minus 9. Now, unfortunately, we weren't able to factor out a 4, this a value. So we still have a 2 here. So that means that we are going to have to do guess and check factoring on this one. So let's refresh our memory on that. So this happens when we don't have a 1 as an a value. Now the nice thing is 2 is not a lot bigger than 1. In fact, it is a prime number. So the only factors of 2 are 2 and 1. So I know that in one of these parentheses I need to start with a 2x and the other one with an x, because that's the only way that I can get this 2x squared term. 2x times x is 2x squared. Now comes the guess and check part, because 9 has factors of 1 and 9, but also 3 and 3. The other thing I notice is that I have a positive sign here and a negative here. So I'm going to need some combination of positives and negatives. And so here is where the guessing part comes. It's an educated guess because we are narrowing it down to one of these sets of factors, but we could put a 1 here and a 9 here, or we could flip them, 9 and 1. We could also put a positive negative or negative positive. So we have 4 combinations just with 1 and 9. Positives and negatives and being flipped, and 1 and 9 being flipped. I will tell you, if you run through those, they are not going to check out. So we're going to cross through that and pretend we ran through all 4 of them. Now let's look at 3 and 3. Well, I know that I can put a 3 here and a 3 here, and those are actually pretty set because if I flip them, well, it's still a 3. But what's not set yet is our signs. So first I'm going to try a positive here and a negative here, and let's try checking it. I'm going to have a 3 times x, 3x, and a 2x times negative 3, negative 6x. So negative 6x plus 3x is equal to negative 3x. Well, that's not what I want. I want a positive 3x. You don't have to write this off to the side if you don't want to. I'm just reminding you how this works. Okay, so this isn't going to work. So next I'm going to try swapping the signs out. Negative 3 and positive 3. And now, let's cross this one out. Now I'm going to have negative 3x plus a 6x. And so that will be a positive 3x. And yes, now I have the number that I needed. So my guess and check is done. And I'm ready to continue solving. The next step to solving is setting each factor equal to 0. Well, it doesn't make sense to set 2 equal to 0. 2 is not equal to 0. Since there is no x value in this greatest common factor, I could divide it out, and 0 divided by 2, still 0. So let's focus on the next one. We have 2x minus 3 equals 0. And so moving things around, move the x or the 3 to the other side, we'll give it a positive 3 and then divide by 2. X plus 3 equals 0. Well, x will be negative 3. Now, one last time, we need to do our check. So when I do the check, x cannot equal, let's see what we had here. We had x minus 3. So if I put a positive 3 right here, I would get 0, and I don't want that. So x can't equal 3. And the other thing x can't equal is, well, a negative 3, because negative 3 plus 3 would also be 0. And we don't want any part of that in these denominators. So x can also not be negative 3. All right, so x is equal to 3 over 2. Not a positive or negative 3, but this one is. This is a negative 3, and so this is an extraneous solution because it is one of our excluded values. You could also see that if you started trying to plug a negative 3 in for x up here in the original equation, the purple part. If I plugged a negative 3 in here and then took negative 3 and multiplied by negative 3, I'd get a positive 9. 9 minus 9 is 0. We can't have a 0. Same thing here. Negative 3 plus 3, 0. We can't have that. The only place it would work is in this first one, but it has to work everywhere. We can't have zeros in any of the denominators.